Thank you so much for joining. She is a really wonderful collaborator, Foresight Fellow, and has been working with us on a tech tree that is basically mapping out the space that many people in crypto computing and AI are working on, and trying to get a little bit more of an idea of what people are working on and having a decentralized lens on it. Thank you so much for joining. I will get out of your way and I will facilitate questions when we get there. Cool.
Okay. Thank you, Allison. And hi, everyone. My name is Ying Tong, and I'm a cryptographer. I work at the Electric Coin Company, and basically we maintain the Zcash project. So if you're not familiar, Zcash is an anonymous cryptocurrency, and my motivation for being in this space is that I care about privacy, and I think that financial privacy is a prerequisite for any other form of privacy. And I think privacy itself is a prerequisite for a democracy. So I got interested in this tech tree project. Basically, a tech tree, if you're familiar from the game Civilization, it's a data structure that maps out in a sort of linear fashion the progression of a certain space. So it maps out basically the dependency graph between different technologies, and it lets you spot where on the graph you are and what you need to achieve in order to get to your end goal. And for this intelligent cooperation tech tree, the thesis, that the end goal thesis is something like this. So blockchains and decentralized consensus systems enable many agents to coordinate without trusting each other, and enable these agents to play positive sum games. And one of these agents in the near future could be an AI, could be some non-human intelligence, some entity that is playing these games with us. So the intelligent cooperation tech tree is exploring the areas of decentralized consensus systems, as well as artificial intelligence, as well as cryptography and private computation, as well as data governance that make all these possible. Also, just interrupt me at any time if you have questions, actually.
We have about 10 more minutes for the job.
Oh, okay, don't interrupt me then. Yeah. So I guess I'll start off. I want to start off by showing you two historical versions of this tech tree. And the point I'm trying to illustrate is that the tech tree endeavor itself is not a trivial one, and I found it to be a lot more difficult than you might expect. So this was the first prototype of the tech tree, and basically it involved a lot of compound nodes. It involved a lot of nested structures, and it reflected the structure of the space at multiple granularities. So my thesis was that the most zoomed out version would give you high level insights and would show you the overall structure of the space, and sort of expanding out each section would give you a finer grain understanding of how some of these details might dovetail. And the second version of it, which is, I think, currently live on the Foresight website, we haven't updated it yet. It was quite similar to this, but it introduced a sort of linearity. So a kind of progression where for some of these categories, we're further along, and for others, these are our stretch goals. But still, we can see the nested structure. And the version I'm showing you today, it does not have the nested structure, and it just shows you directly the relations between the lowest level nodes. And I actually found this version to be different versions certain. I think really we emphasize the precision of the connections, and we emphasize basically what exactly each connection means. So how you navigate this very complex looking graph is, my suggestion is to use the highlight by tag feature. So this is an in-house tool that Foresight developed. So where you can label each node by a certain tag. And if I pick, for example, the artificial intelligence tag, it'll highlight a subgraph. And these are the nodes that pertain, where previously we would have had a box surrounding it. Now they're more free floating, but you can still highlight them, and if that's your particular interest. And besides just the topical sort of label, we also have this categories like risks, applications, core technologies, and frontier technologies. And so the idea here is that someone who's new to this field could identify quickly which are the frontier technologies that are high leverage and which are the interesting unsolved open problems that basically everyone else in the industry is also working towards. In terms of the topical labels, that would be the fastest way to introduce this tag tree. So we've seen artificial intelligence here in this lower left subgraph. We also have data governance. So data governance is an interesting one, and it came out of my building this tag tree to realize that data governance is integral to the whole space of intelligence cooperation. It is like the base layer requirement. So like data integrity and data quality and data management is, without that, you have no machine learning and you have nothing to train your models on. And the same is true for blockchains and decentralized consensus systems. So data availability is one of the biggest and most interesting problems in the blockchain world right now. And if we cannot even come to consensus on what data the system has, then there's no point doing any computation on top of it. So yeah, I hadn't realized this previously, but looking at how spread out the data governance nodes are on this graph, it shows me that this is a common concern across the whole intelligent cooperation space. And then there's decentralized systems. So these are basically, it's a very colorful subgraph because it involves the whole range from core technologies to applications to frontiers, as well as several challenges. So the challenges here in particular, one use case for this tech tree is to highlight challenges that could then be translated into bounties for people. So we create these requests, these open problems, and we put them out. For example, Sybil resistance. Sybil resistance is the ability to defend against a spoofing attack. So a single entity pretending to be multiple people that would screw up any identity, any system that's based on identity. For example, a voting system. For example, a funding system based on votes. So Sybil resistance is one of the big challenges in the decentralized computation space. Another challenge is maximal extractable value or minor extractable value that basically arises from an asymmetry in the types of players involved in the decentralized computation space. So there are people who transact, and then there are people who order and include these transactions. And the latter class of people has the power to order the transactions in a way that advantages them. So for example, if they see a huge buy order on an exchange, they could sandwich it strategically in order to profit from that order. So yeah, this is just highlighting a use case of the tech tree that we can identify challenges and we can create bounties for them. So the next category is private computation. And this is what I work on for my day job. And again, you can see that it was really interesting to me, like these, much like data governance, private computation is also a fundamental concern that spans the whole intelligent cooperation space. And the reason became clear to me after making this tree. So for decentralized systems, many of them, in order to meaningfully work, depend on privacy and anonymity. So the challenges we talked about just now, maximal extractable value and civil resistance, they both can be solved by privacy and anonymity. And we can discuss this in detail offline. Whereas in the artificial intelligence and machine learning space, there's been efforts towards basically better dealing with sensitive data like medical data, financial data, and making meaningful computations on those without compromising privacy of the owners of that data. So things like fully homomorphic encryption is not practical right now, but people are looking into that. Things like differential privacy and federated learning as well. So privacy concerns also span the entire space. I think those are all the topics and categories in this tree. So with what's left of my time, oh, I want to show, I just did this thing on the train over here. I wanted to show the benefits of having a graph structure. So this is just a Python notebook. But basically, if you have a graph structure, you can do a bunch of analysis on it. So for example, number of nodes, number of edges. Okay, that's boring. So for each category, how many nodes are in the category? And there might be some asymmetries here because I personally work on private computation a lot. You could show more interesting things, like for example, how many source nodes are there? How many nodes do not depend on anything? Like they're the origins of everything. Everything else depends on them. Or, you know, conversely, how many sync nodes are there? The sync nodes are probably at the rightmost of the graph. Like everything's leading to them. So how about what are the top blockers? What are the nodes that block all the other nodes? And for each of these blockers, so for example, censorship resistant computation, you can see what exactly are they blocking. And you can imagine we can visually highlight this too on the graph. So what are ZK snarks? What do they unlock? So if I unlock soulbound tokens, what do I get? And then conversely as well, what are the top frontiers? So what are the nodes with the most blockers? So in a sense, the nodes that are most difficult to achieve. And for each of these, oh, this always happens. The demo got, okay, I think my time is up, but I hope you get the idea that we can do a bunch of fun graph theory analysis, like shortest path, longest paths, most connected subgraphs, stuff like that. I haven't even started to do. Yeah, that's it for me. Yeah.
Wonderful. Oh God, so much progress. Like to provide some primer, like we have the same tech tech for tech discussing the tool and for and they were kind of like wish for building out kind of like trees that map the fields you guys are all working in, so that people enter the fields quickly, see what to work on, what are the actors in the space, through challenges we can like fund specific work in that space, but also for you guys, for example, if you want to collaborate cross-disciplinary to figure out what are the people in the molecular tracking working on, how is this relevant to longevity and like to the kind of therapeutics that I'm developing like 5 years from now. And so that's the reason that we're doing this. And so thanks a lot, Ying Tong, for doing such a fantastic job presenting. And
I have a lot, so I will connect with you later.
Yeah.
I've been working with some roadmap for these areas as well, so I will follow you.
Yeah.
Great.
My group has like recently built a coalition that's going to be working in the space of pro-social technologies, and this is so magnificent. Is there a way that we can, maybe I'll ask you offline in front of everyone, if there's a way to like work with some of these skills.
Yeah, I
We're
think.
doing our own landscape analysis.
Yeah. I think like what I love about this tech tree is like it's a living thing that people can interact with, like you can drag and pull and like add to it. And so we need to build out like a pipeline for collision. I think that's should be a top priority. Yeah, and I think it would accurately reflect the ecosystem if it's built by the ecosystem. Yeah.
I do want to say we have a lot of people now creating their own different nodes of the tech tree. For example, within longevity, we now have a few people building out the ECM node, and then a few people building out the artificial womb node. And so all of these, people are now coming out like uses from my sub community, and then we can slot it back into the main graph. And like obviously, it's much better filled out if people actually that are working on it fill out who the main actors are, what are the main challenges, and the ideas that over time we can then provide funding for these areas, like have a bit of a faster way where people can orient themselves, that it's not just a report or something.
Are you tracking the evolution of the tech trees somehow with GitHub as some open source tool to see how it
Yeah. So for me, every update I make is a Git pull request. Yeah. I think that's the best way to track it. You can see the diff each time. I definitely think the backend should be GitHub or some version control system.
So we can backtrack and see
Exactly. Yeah.
Fuck and what was wrong.
Yeah, that's why I also went through like the history of the tech trees. Like those are just previous commits, Yeah.
What's the format of JSON?
It's a JSON, yeah.
It's super impressive.
How can we reach you?
Well, the tech trees are all on the website, so
No,
it's
no.
all set up.
I have a Foresight email.
Great.
Yeah, and on Discord.
And on
If you're on our Discord, then you should be able to find it.
Yeah, there's an intelligent collaboration tech tree channel on the Foresight Discord.
There's actually an entire tech tree channel, so
Ah.
most often like they are always uploading their progress in that channel whenever they have like a new commit, and I think that could be a good one to just stay up to date. Like our hope and dream is that by the end of this year we can actually push it out and like open source it more. So what we've been building is like the back end of like people that like know the space really well, like Ying Tong for this, Romain for space, Aaron for longevity, and then by the end of this year, the hope is that we can push it out and other people can commit comments. So you can already comment on this tech tree if you want to. And so like the idea is that we can actually have people comment like, hey, there's a lab missing over here, or like, there's a challenge over here that I want to add. And over time, we can then on the back end see, okay, which makes sense to contribute and have a bit more of a like really open source approach to this, including eventually, hopefully, funding bounties open source. So you can imagine, for example, if you had the tech tree and people proposed a challenge that they really want to see solved, someone else could just add funding. That could be as easy as a QR code, which is something that like Ken McConney suggested from Ocean DAO, but it could also be like actually a syndicate DAO that forms and like lots of capital for someone to propose a way to solve a specific challenge. And then they in the back can review proposals and like fund the proposal through investments that like most makes progress on the challenge. You could do this with IP activity. You could say like, okay, everyone who like who puts money on that node gets a fractionalized IP activity. So it's like a more decentralized way of like funding to specific goals within a space. So this one is like more the private decentralized computing one. This space one is first asteroid mining, then a bit further. Then you have the neurotech one, which basically interfaces and mobile emulation is the goal. And then you have the longevity one, which is longevity escape velocity, so rejuvenation.
And we have been happy to collaborate on the technical side. We have been developing for the government now GitHub action and etc. So we have this research repository also on IPFS, so we can develop faster within Insight. So if you want for the GitHub action, I would be happy to open source this.
Just stepping on this conversation, Protocol Labs is interested in, you mentioned IPFS. Protocol Labs is interested in collaborating to the backend of this, especially in terms of decentralization and protocols to merge different graphs. So you mentioned the GitHub backend. So if you have ideas, we are setting up a group of people to kind of scope down these ideas and hopefully deploy this kind of protocols. So these are more than living visualizations that can be like a collective exercise. So Foresight Institute has done a tremendous job on this. We just need to collaborate with what we can, and we think it's graph protocols and consensus protocols for graphs. Or can we gather consensus that this is an important node to be on the graph? And blockchain has a lot of things to do so. I don't know. I won't know your names, but hopefully we can connect you.
You'll be happy to hear that after this the session block, we'll have a tech tree social. So basically, every tech tree lead will be in their room showing their tech tree, and everyone who's interested in that tech tree or generally socializing around that node. It's like an icebreaker basically that we're doing with the tree. So if you guys want to just be in this room, that works well. We will book club over here, but we won't talk too much.
And yeah, just kind of adding on to this, kind of just for other reasons, I've like been working on like a Solidity primitive for building like on-chain graph structures. So if that's like applicable or interesting to anyone, I'm happy to talk about that in person. This might relate here as well.
Wonderful. Well, thanks a lot, Ying Tong. Very exciting.